Good morning, good afternoon, and good evening. My name is Tim Devling from Xstrahl, and we welcome you to this webinar today. We have been working with SmART Scientific Solutions for both the SmART-XPS treatment planning software for the SARRP system and the SMART-RAD cabinet dosimetry software for our 6 cabinets for many years. So I'm pleased to welcome Joël de Bruijn, R&D Engineer at SmART Scientific Solutions, to speak about the AI-driven auto-contouring for treatment planning on the SARRP and the many developments that they have in the pipeline.
Thank you, Tim. Hello to everyone. I'm Joël de Bruijn. I'm a research engineer at SmART Scientific Solutions. And today I'm going to tell you a bit about SmART-XPS. So let's first start with an introduction. Who are we? We were founded in 2015 in Maastricht, the Netherlands, which is a city in the south of the country. We are making products for preclinical radiation research, and we have strong relations with the academic world. And just to highlight that, this is a map of the campus. You can see that we are located in the south, and to the north of us, there's the academic hospital. You have the University of Maastricht, and you also have Maso Clinic. So there's a lot of knowledge combined in this one campus, and we actively work together with the other parties. So yes, it's a very very smart campus. So one of our main products is the preclinical treatment planning. We have image-guided treatment planning, which is SmART-XPS. It's the main topic of today's webinar. This is image-guided. As you can see, there's a CT that we base our treatment plan on, but we also have non-image guided, that is SMART-RAD. They can basically do the same things. The only difference is that SMART-RAD is non-image guided, so you work with phantoms instead of CT data. So let's start with SMART-RAD. SMART-RAD is our product for non-image guided radiotherapy. You can see on the right hand side of your screen that there's a mouse phantom. This mouse phantom has a tumor and a shielding, and that way we can model what is happening inside your radiator. We do Monte Carlo dose calculations, and we have a flexible experiment setup where we offer support for different specimens. So this includes mouse and rat specimens, as well as cell cultures. We offer support for different fixation materials, shieldings, tube energies, and filtrations. We have a number of dose evaluation tools, and we have an automated dosimetry report. So resuming, SMART-RAD is the product that we make for non-image guided radiotherapy. We also make micro-CT calibration phantoms. You can see one in this image, and the phantom has 10 inserts, and the inserts are tissue equivalent. And that way, if you have a CT, you can automatically calibrate the mass densities of the CT. Now we've come to the main topic of this webinar, SMART-XPS. So SMART-XPS is our image-guided treatment planning system. You can see from the CT data that we use to set up the treatment plan. The goal behind SMART-XPS is to give you an intuitive workflow for radiation planning. So we have really optimized for ease of use. So even if you're not an expert, you should still be able to use SMART-XPS. Yet we still have advanced options available. So if you want to do anything more complicated, complex, then we still have these options available, but you don't have to use them if you want to set up a simple treatment plan. We developed SMART-XPS with feedback from researchers. One example is the auto-contouring module that we will discuss later on. The auto-contouring module was tested at a number of universities that we collaborate with, and we use that feedback to make it even better. So we work with modules. As you can see, on the bottom of the screen, I have made a slightly bigger version of the taskbar in the top. So these show the modules, and the goal is that you work from left to right. You start with the setup, then CT to MD, all the way to the export of the data. But we made it in such a way that you can also skip modules if you don't have to use them. So SmART-XPS uses Monte Carlo dose calculations. So this is the gold standard for kV X-rays. You can see on the right on the image that we have the CT with on top of it a nice dose distribution that comes from the Monte Carlo dose engine. We are completely DICOM compatible. So this means that we can read in DICOM data, but we can also output that DICOM data. So if you're done, you can save your data as DICOM. And another good point is that we have direct communication with the SARRP. So if you're using SmART-XPS, you can set up your treatment plan, and then you can send this directly to the SARRP. So this is SmART-XPS. We are in the setup module at the moment. The setup module is meant to import data. You can see that we have the modules in the top. And again, we start with the setup module because we first have to import data. We can import a DICOM CT by clicking browse, then opening it. And then we can see that indeed there's a CT in this folder. We can import it. And now we have our CT loaded. So this is a CT to MD module. You can see that we have loaded our CT with the full displays on the right. And now we have to assign the right medium to the right tissue. For air, we can use it a manual threshold, but we can also detect it automatically. Let's also add a medium for the bone. And then we have to select the bone. And we will make this green to make it better to see. Let's make sure that indeed we have all the bone assigned to the right medium, and that is the CT to MD module done. So we are now in the auto contouring module. You can see that we have the full displays again on the right, and we have automatically segmented the 5 organs on this CT. This has been running while we were on the CT to MD module, so it happened in the background. And now we basically have the segmentations of 5 organs: the bone, the brain, the heart, and both lungs. So we can evaluate if the contours are correct, but to do that, I would first like to change the appearance a bit. So this way we can evaluate a bit better. We can scroll through the CT volume, and then we see that we indeed have nice organ contours. Just to show you, I will also show you the other dimension. And if you look carefully, there is one mistake in the CT. We have segmented part of the nose cone as a bone. That's incorrect, and to remove this mistake, we can click on it and it's gone. So if we are happy with the contours as they are, we can click on accept structures and then convert them. We also have options for manual contouring. This is in the contouring module. As you can see, we have again the CT. We already have 5 contours that we have received from the auto contouring module. This module also has some drawing tools. So you can see in the bottom of the screen that we have a number of drawing tools. But to show you, we can also add another contour. We can, for example, add a tumor. We can give it a pink color. And let's just make a fictitious tumor in the heart, just to give you an idea of what we can do. We can segment a few voxels in the heart. And then every few slices we make some segmentation. And then we interpolate, and that way we now have a 3D fictional tumor in the heart. You can see in the other dimension indeed that we have a 3D volume. So this module has a number of drawing tools that you can use to make new contours. We have the freehand, the brush, region drawing, and interpolate. And you can also modify the contours that we got from auto contouring. So if you see any mistake that came from the auto contouring module, you can still correct it in this module. So we are now in the planning module. You can see that we have the CT with the contours that we made. In the planning module, we can set up a treatment plan. To do this, we can add an isocenter, and we can move it to the right place by clicking and dragging it. So that way we can move it to the tumor. You can see that by default, we give it a dose of 2 gray. Let's just keep it at that. We can add 2 beams. The first beam, let's just drag and put it in this position, and the second one, we can also click and drag. Just to show you, we are going to change the collimator of the second beam, and now we've basically set up our treatment plan. I think this module also highlights what we wanted to do with SmART-XPS. So you have a very simple, intuitive setup. You can create an isocenter, you can create beams, and if you want a very basic plan, then it's very simple to create it. If you want anything more difficult, you can see on the left we have a panel with more support for more advanced planning. So now we're in the calculation module. You can see that we have set up our treatment planning, the planning module, and it is imported into the calculation module. In this module, we can do the Monte Carlo dose calculation. You can see that we already have a number of histories as a suggestion. You can click on start, and now the dose calculations will start automatically. So now we are finished, and we can check the results. You can see that in the CT, we now have a nice dose distribution. And we can also check the other plane. And you can see that it is actually what we would expect based on the plan. So again, this module is very simple. If you want to use it in a basic workflow, you can just click on Start Calculations. But if you want something more advanced, then again, we have more options hidden. Now that we have done the dose calculations, we can go to the evaluation module. And the evaluation module is meant to look at the simulations that we have. The evaluation module has dose volume histograms and dose volume metrics. We can look at the dose volume histogram, and you can see that indeed for the structures that we have a nice dose volume histogram. And then we also have dose volume metrics. So you can see that we have the volume and several metrics. And if we go back to the dose volume histogram, you can see that this way you can evaluate if an organ has sufficient dose or that you should maybe spare an organ. So this is a very nice tool you can use. You don't have to use it, but you can use it to optimize your treatment plan. And the last module is the export data module. This module, as the name suggests, can be used to export your data. You can export your data as DICOM on the left-hand side, where you can export the dose distribution, the structures, and the beams. And you can export the irradiation plan. This irradiation plan can be sent directly to the SARRP, and that way you can directly use the irradiation plan that you've set up. One thing to highlight is that we have a flexible geometry. We support the same degrees of freedom as the SARRP. We support a motorized variable collimator, which means that we have the full SARRP range of motion, and we support collimator rotation. We also support multiple irradiation and imaging spectra, and we support variable current. Let's now talk about Smart Contour, which is the outer contouring module in SmART-XPS. So normally in preclinical radiotherapy, you have a specific workflow. You start with your animal setup, then you do CT imaging, you do organ contouring, then you do treatment planning, and you deliver your irradiation. So all of these points, they take up some time, but the biggest bottleneck of them all is the organ contouring. So we found out that it takes from about 15 to 45 minutes, depending on how many organs you want to do and how precise you want to do it. And because this is a huge bottleneck, we came up with Smart Contour. So let's ask ourselves a question: why would you do organ contouring in the first place? So one reason would be to spare the organs at risk. One reason would be to study the effects on organs, and for those two, we have the dose volume histograms and the dose volume metrics in SmART-XPS. But you can also do it to do radiomics analysis. So of course, if you have a nice contour, then it's much easier to do this radiomics analysis. So what are the advantages of Smart Contour? The first one is that you save time. So manual contouring will take anywhere from 15 to 45 minutes, and automatic contouring will take under a minute. You will gain extra insight, so you could do a number of extra analyses, as well as make a mask for radiomics. We currently have 5 organs: the left lung, right lung, heart, bones, and brain. And the goal is to offer you easy editing tools. We have several post-processing tools with drawing tools, and the goal is that you can do a quick assessment of the contours and then continue with your workflow. Let's quickly talk about the development of Smart Contour, because there's one thing that's really important about this. We start with CT images. We did manual delineation. We trained a neural network, and then we tested using an independent test set, and then we implemented it into SmART-XPS. You can forget all of this, but there's one thing you should really remember, and that's that we use an independent test set. So why do you do independent testing? To illustrate this, I've made 5 images. So these 5 images, they show CT scans of mice that look completely different. So you have a thorax crop, but you also have one where there's 2 mice in the CT. And it's really important to really do an independent testing, because you want the AI to still work even though your data looks completely different. So that way, even if you change the CT protocol, even if you change the reconstruction algorithm, it will still work. And a fun fact is that all of these contours were made using Smart Contour. So you can see that even though we have vastly different data, it will still work. Something I mentioned before was post-processing, and let's have a look at why you would do that. So to illustrate that, I have a slide where I have a few examples of AI making big mistakes. So I think we can all agree that smoking cigarettes while pregnant is not very good. But we can see that the AI just makes an output creates an output that we would not expect it to make. And this is from the best AI in the world. So of course, we will eventually also make mistakes. Now, what does it look like for us? We have a CT where we have a mouse with a blob of brain in the jaw, and you can see that a part of the skull is missing. So you can see that we also make mistakes, but they look different than, for example, when ChatGPT makes them. So we are back in the auto contouring module. You can see that I have already ran the auto contouring. You can see that again we have the same CT as before. We have the mistake in the nose cone. We can click on it to remove it. That is one way we can do post-processing, but also you can see on the left-hand side of your screen there's several options for more advanced post-processing. Normally you don't have to use these, but in case you want to edit something, you can still do it. There's more advanced options available. So let's create a roadmap for Smart Contour. There's a few things that we want to add in the future. We want to have additional organs, and we have already been doing some work on that. We want to be able to segment muscle and adipose tissue. We want to do tumor segmentations, which is quite challenging. And we also want to be able to contour abnormal tissues. So one example is lungs that have been exposed to severe radiation and that have fibrosis. So what are we working on? We are working on open field planning and virtual setups. So in the beginning of this webinar, I talked about SmART-RAT, and several features from SmART-RAT will be implemented into SmART-XPS. We are working on MiraGlow support, on irradiation plan templates and defaults, and we are improving the display. So you can see in the GIF on the right-hand side that we have been working on a more flexible display. You can do now rotating, panning, and zooming, as well as take oblique slices. One thing that we've been working on is the integration of a radiomics package, and you can see on the right-hand side that we have a prototype ready. It's not ready yet for SmART-XPS, but we are working on it. And another thing is automatic updating. So that way, every time we improve something on SmART-XPS, you will get an automatic update. And the last thing that I really want to stress is that we take the feedback from the community serious, and we adjust our development to it. So if there's any needs, then we are more inclined to give that a higher priority. Some closing words. I have a take-home message that consists of 3 points. The first one is that we have SmART-XPS for image-guided preclinical radiotherapy, and I hope that I've given you an idea of what you can do with it. The second one is that we really design it to be intuitive, and we really optimize it for ease of use. So it's very simple to use, yet we still have the advanced options if you want to do something more complex. And we now also have Smart Contour, and that allows for an even smoother workflow. So we hope to see you at the next SARRP user meeting. And if you have any interest in SmART-RAT, that's something that we also did a webinar on with Xstrahl. If you want to know more about that, then check out the previous webinar. That's it. I want to thank you for your attention, and if you have any questions, then please let me know.
Thank you very much, Joël. That was an absolutely fantastic presentation. So we'll get to the questions, and for the question sessions, we are joined by Stefan van Hoof from SmART Scientific Solutions as well. You can type the questions into the question chat box, and we'll have plenty of time to get to them. So I will start with the first questions. Let's start here. Which organs, Joël, do you think it will add most value to for auto contouring?
Thank you, Tim. So we currently have 5 organs. We have the both lungs, we have the heart, the bone, and the brains. We saw a paper a couple of years ago that listed the most controlled organs in preclinical radiotherapy. And of these 6 organs, we have 4 of the 6 most controlled organs, which are the lungs that were combined in that paper, the heart, the bone, and the brains. So we really try to target the most used organs. I think in terms of time saving, it's the bones, because the bones take up quite a bit of time. So yeah, these are the organs that would add most.
Cool. And you mentioned about the idea that you could contour abnormal tissue. That could be, I mean, that would be an absolutely amazing thing to be able to see fibrosis in the lung or other sorts of abnormal effects of radiotherapy. How long do you think that will take to get in operation?
That's difficult to say. We did, however, do some exploratory work. So I have a slide on that. So we did do some work on these organs. We have done some exploratory work for the spinal cord, the kidneys, the spleen, the liver, the bladder, and the eyes. So these are the extra organs that will come in, that might come in if we have it working stable. Then we also want to start looking at the tumors. That's quite difficult to do. So of course, tumors can grow in many places, can have many shapes, many sizes. So that's quite a challenge. Yeah.
Okay.
The
Cool.
challenge is that tumors are like abnormal tissues, so you don't really know what to train for. And in general, the most difficult hurdle in developing this is to get sufficient amount of training data. So contouring abnormal tissues will be the most challenging one.
So I guess if anybody's got any data sets, I'm sure you'd like to get your hands on them.
We'd love to.
Definitely. Yeah.
Is the isocenter definition always manual, or have you considered automatic centering based on the tumor's barycenter?
Good question. At the moment, it's manual, and since we have click and drag, so you can just basically drag it anywhere you like. It usually just takes a few seconds to position it at the place you want. But we are going more into the direction of having 3D structures, especially with auto contouring now. So it would be easy to add something like, okay, position the isocenter at the center of mass of this structure or so. To be honest, I don't think it will really do much for time saving, because it only takes a few seconds to reposition your beams. So that's a good point.
Okay. Slightly off topic, well, semi off topic question. We have seen SmART-RAD. You mentioned SmART-RAD in the talk. Does this mean we can use this SmART-RAD planning for total body irradiation on SARRP?
Yeah, SmART-RAD is really customizable because it's really meant for different types of cabinets. And if you use like a static positioning for irradiation in your SARRP, there's no reason why it will perform worse there. So yes, you can use. You can also set up SmART-RAD for your SARRP as well. It's not something that we have done yet, but it makes sense to do it if you're into that kind of research types. Yes.
Cool. Can I use the auto contouring module with Murray plan?
It's a good question. Currently, we have implemented it into our treatment planning systems, the image guided one, SmART-XPS, but we don't have any integration with Europlan. However, if you have SmART-XPS, you can export the contours as RT-structs, and if you have an RT-struct, you can read that in with Europlan. So that way you can still use them.
And I'd probably say if you are interested in SmART-XPS and auto contouring, just get in touch with us, and we can always talk about trying it out if you're currently using Murray-Plan.
Sure.
Now, a tricky one. Can your software calculate the delivered dose of irradiation? You may mention, but I didn't quite catch it.
So I guess the question is the actual delivered dose by the SARRP. That not really, because there's no real feedback from the SARRP back to SmART-XPS. So at the end, it doesn't really know what the machine will actually deliver. But it's a good point. It's something that has been definitely on our radar as research project, and then more in terms of like dose guided radiotherapy and maybe using the imaging panel or so to assess the beam as it comes out of the mouse again, and then see and then compare that to a simulation of what it would need to be. But it's not something that it's implemented at this moment, and it will also not be very soon that we would do that. We haven't really heard back from the community. It's something that people would like to have. But of course, all the SARRPs get set up at a decent commissioning, SmART-XPS as well. We measure all the beams in high resolution using film. We do proper measurements of the output, including ramp up, ramp down effects, which you can also include in XPS as well. So the setup from the beginning on is a full commissioning. So yeah, we're quite confident that the calculated treatment plan is also very close to what will be delivered to the mouse.
And possibly an easy question now, will you include MRI image registration? I think that's there, isn't it?
Good question. Yes, we already have it. It's already in XPS at this moment. You can already import secondary image data sets, which can be pretty much all 3D image data sets that are in DICOM format, so PET, CT, MR, SPECT, and you can also import 3D MR as well. Which you can then register to your primary image data set, which needs to be a CT image. That registration is manual rigid registration at this moment, but we are seeing more and more sites that have interest in using multiple image modalities, or maybe doing like fractionated schemes, and where you want to compare a plan of one day to the CT image of another day. So it's something that we have on our radar also, maybe to make a bit more flexible. But you can do it now, basically.
Cool. Next question: can you do auto contouring on 2 mice or multiple mice in the same CBCT?
Yes, you can actually. I also have an example of that. So you can see that we in this slide we have 2 CTs, and we have 2 examples of a CT with 2 mice. So you can see that it works both for crops of the thorax, but also for entire mice. So yes, you can.
That's great. And do you think there'd be any strain differences or male and female differences in how the auto contouring works?
That's a good question. So that is something that during the development of Smart Contour we really also looked at. So of course there's biological differences between the strains, between male and female, and that is also why we, when training the AI behind Smart Contour, we had a training set that contains mice of different strains, mice of different sexes, and we also use a training set that also contained different mice, and we didn't see any big difference between the performance on different mice. So yes, it can do both. It can do both both sexes, and it can also do the different strains.
Thank you very much to Joël from SmART Scientific Solutions for giving us a fantastic and interesting insight into what SmART-XPS can do. And with that, I'll end the meeting and wish you all a fantastic end of your day.
Thank you. Thank you. Bye-bye.